So today we're doing a little activity on exponential growth. Okay? Our objectives today are number 1, to investigate exponential growth. Now this is something that was not on your tax test. It's something that sometimes math teachers and science teachers skip over because you're not going to be tested on it. But it's something really good to know because actually you do have to know stuff about exponential growth in real life. Okay? So we're going to study it in nature. So where does it happen out there in nature and also in your cells? We're going to calculate it. We're going to graph it and describe trends. And as a language objective, I would like you to be able to orally and in writing describe what happens with exponential growth. Okay? So, exponential growth, where do we see it in nature and how do we calculate it? Can somebody tell me where we see exponential growth in nature?
Plants.
Good, so tell me how.
Photosynthesis.
So, photosynthesis, exponential growth within the cells. Okay, good, so cells keep on growing. What about like numbers of animals? Rats? Rabbits, good, and that's actually going to be an example. Good, so for example, if you were a pet store owner, okay, and you were breeding rabbits, and you bought, let's just say, Linda's Flower Patch, that's for sale, okay? Now, is that a big building? No. So what is something you might need to know if you're breeding rabbits?
The reproduction rate of rabbits.
Reproduction rate of rabbits, awesome. So that's where we actually do have to calculate exponential growth. Awesome. Okay, so the first thing I want you to do is we're going to watch a video on the exponential growth of bacteria. In 1 or 2 sentences, just describe what you're seeing. Okay? So we're going to get a petri dish. Okay.
Whoa, dang. Is that like normal time or is this?
No, so that's a good question. This is actually sped up because usually bacteria might take like an hour to grow. Your real cells can take, up to a week to divide. Okay, I'm going to play it one more time. Just describe to me what's going on. Good. You can describe like the size of the cells, like is one cell just keep on getting longer? Or
There's more and more.
good. Does somebody want to share what they wrote?
I was like, the cells, it looks like they grow, and it looks like they split in the middle, then they keep growing, they split in the middle.
Awesome. So you already know this from mitosis in middle school and high school. You have to get bigger and equally grow, and then you divide. And then you get bigger, and then you divide. Good. Now, do you think there was like a rate of growth? Like, did it seem like they kind of grew, then stopped, and then grew a whole bunch more, and then stopped? Or did it seem like it was equal? And it was constant. Good. Awesome. Okay, so these are going to be your notes. What I'm going to do is I'm going to go through these, and I want you to copy these down. Okay, so first off, biological exponential growth is just the exponential growth of things in nature. Okay? This can be organisms in a population, or it can be things in your body, your cells. Because remember, your cell is your basic unit of life. Now, when resources are low, that's when exponential growth is more difficult. Technically, if I kept on giving you food and water and shelter and money, okay, you'd be able to grow and grow and grow, or build and build and build, but a lot of times, some of these are limiting factors. Somebody tell me real quick, if we were studying rabbits in Bremond and we had a drought, what would be the limiting factor for the rabbits in Bremond? Water, and then what else too? Food, because the water affects, good, the photosynthesis of the grass, awesome. And then also, if they couldn't burrow underground, if the ground was bad, they wouldn't have shelter either. Okay, so ideally, if they had all this resources, they'd be able to grow and grow and grow. But in real world, we can't do that. Especially humans. What happens to humans? Do you think the humans are just going to keep on growing, growing, growing? No. We're going to reach something called a carrying capacity. So y'all have heard that in biology. Think of your book bag. Okay, what is the carrying capacity? How much can your book bag carry in terms of books? What do y'all think? What is the carrying capacity of your book bag? 5 books. Good. Can you fit more than 5 books in there? If you do, what's going to happen to your book bag? Good. That's what happens in ecosystems. An ecosystem can only support X amount of organisms before the ecosystem falls apart. Okay? Does anybody have a tank at their house?
Got it.
Okay, so what are some organisms that live in your tank?
Frogs.
Fish,
Fish, frogs,
Turtles.
turtles. Good. Now,
snakes.
snakes. Okay, so do you see like every day or every year more and more and more, or is there a constant just X amount?
I want fish powder.
Depends on how much it rains.
Depends on how much it rains. Good, so you're depending on factors. Also, the space of a tank. I don't know if y'all know this, especially with reptiles or like snakes. Your snake will grow as big as its container. So people who have snakes in cages or aquariums, they'll kind of stay small. But those people who leave their snakes out in their house and give them like rats and rabbits to eat, they get as big as your house. They get as big as their home. Okay? So their carrying capacity is a lot bigger than that of something that would be living in an aquarium. That's why they say that they grow enough to be longer than their owner so they can eat their owner.
My snake would eat it.
I wouldn't want to chance it.
These have turtles.
And that's another thing too. Turtles, like if you buy those cute itty bitty turtles from the pet store, if you put those in an aquarium, they'll stay cute and itty bitty. If you would release them into nature, they'd actually get a lot bigger.
One in iguanas.
I have one. These are,
Not really. You pick them up on the road.
no, not that one.
Okay, when you're done with the carrying capacity notes, we'll watch this next video, and it's about the carrying capacity of the world based on the human population. So it's kind of scary how quick our population is increasing, because we have limited resources. Also, does the world always work together unified? No. Give me an example of something that right now, especially with our economy, we're having to pay a lot for, or we don't have that much of. Yes, good. So technically, that's a limited resource, not because we don't have it, but because of our economy, and whether or not we're friends with certain countries that'll import those goods to us. Okay, so there are a lot of factors. Okay. So what they're doing is they're comparing the global population to the amount of billions of people to how big it is. And so now, it's maybe just as big as a landmass, then an ocean. Then it's going to pretty much get as big as like our galaxy. Okay, if this was true exponential growth. So what opposes growth rate? So death rate, good. So at least we're not going to keep on living on forever and replicating forever. There is death.
Is this like without anybody ever dying?
Yes, this is complete exponential growth.
Crazy.
That'd be a lot of people to the end.
You could walk underwater, you can't die.
Yeah.
Walk the fire.
In the universe, it's including mermaids.
Okay, so do we have a problem here? Well, obviously this is not going to happen. Sooner or later the trend will be broken. This can happen our way, or by war, famine, or disease. So they mentioned things like War, famine, and disease. What did they do to exponential growth? War, famine, and disease.
They hurt it.
They hurt it. Perfect.